Maybe this doesn't. All right. So we talked about similar polygons yesterday. Congruent angles, you need, for similar polygons, you need congruent angles and proportional, I can spell, side relationships. So when we look at this first set of triangles, I'm telling you that they are similar. That means all of that information. Oh. All of that information is true. Because I said those two triangles are similar, then that means that I know the angles are congruent, as are marked in the diagram, and I know the sides are proportional. So because I know they're proportional, I can set up a proportion. You learned about this, I don't know, 6th or 7th grade. And so we're going to go the same way both ways. I generally like to go from left to right. It doesn't matter. So that means I'm going to do big over small equals big over small. So that's just how I'm setting it up. So then you substitute, and we pick things that we know from this picture. So I have AC and DF. Now I don't have the names for the triangles, so how do I know those are my sides? Well, this has 1 in the right angle, and this has 1 in the right angle, so those have to be the two sides that match because of the angle markings. So then I'm going to put 21 over X, and then CB and FE, again, from the 2 to the right angle and 2 to the right angle. So that equals 27 over 18. Remember, we just went from left to right. So we're comparing the big triangle to the small triangle. Now, it's just a matter of solving. So we cross multiply. So that means that we do 18 times 21, thank you, and x times 27. So that's 27x equals 378. And then we divide by 27. That's a 1. X is 14. That's it. It is. So that's all we did was find the side that was missing. So let's go look at a couple more examples. It doesn't matter how many sides you have. So again, I just go the way that the diagrams are set up, unless I'm told to compare, like when we were talking about scale factor yesterday, scale factor big to small or small to big. I just go with the way the diagram is. So to me, the diagram goes like that, like that's how I read it. So I need two things. Notice that there are two variables. There's an X here and there's a Y here. So I got to find two different things. So it doesn't change anything. It just means I got to do it twice. So for the first one, you'll notice that 3 matches the X. So 3 over X equals. Now I can't use the 5 because that's an unknown right now. So the one I have to use is the 4 and the 18. So I'm going to use 4 over 18. So then you cross multiply. 4x equals, is that 51? 54? 54. And then we divide. So x is 48, 12, 18. So that's why I keep you around, Samuel. Thank you. It's not 18. It can't be 18. So what am I listening to you for? Samuel? 13.5. Now, what do you notice about that number? It's not a whole number. That's okay. Don't freak out when you get decimals. It's okay to have not a whole number. As long as you've gone through the process, like you need to get over the rest of your life, very few things are in whole. If you've ever gone to the store and spent exactly $20, it was a miracle. So like, it's okay if your numbers have decimals and are not perfect answers. So now that I've done that, and I know that this is 13.5, I've told you before that I don't like to use the numbers I come up with. I always go back and refer to numbers that are given to me, just in case I made a mistake somewhere. So this time, I'm going to use the 5 and the y plus 2. So that's 5 over y plus 2. And I'm going to, again, use the 4 and the 18. I can use it twice. Those sides are still on the shape. I can still use that for my proportion. So we cross multiply. Now pay attention to how you cross multiply with more than one term. Like that's what that means. 4 times y plus 2 equals 5 times 18. So then we have to distribute. 4y plus 8 equals 90 minus 8 minus 8. 4y equals 92. Divide. Y equals 20.5. Okay, 82. Happy? Yep. Thank you. All right. So like this part from here down, that's 6th, 7th grade math. You've done this for 3 years. This is the only part that's kind of new, but you've also set up equations like that. All you're learning is how to pull the numbers and which ones have to match. How do I know that AE matches RV? Especially because sometimes the diagrams are rotated. Right here has one line and one line, and this has, is that 5? I think that's 5 and 5. So we're just looking at the angle markings to find the sides that match. Especially if this picture were like rotated or something, then that's how you do that. It's not hard. So when you look at these, you're just trying to figure out, it should be kind of obvious that these are the sides that match and these are the sides that match.